So if we apply KVL at this source node, we will get this VGS minus VGS2. Now we will add and subtract threshold voltage from in this equation. So now it will be VON1 plus VON2. So this is here minus. So V is given by this equation. V is given by this equation. Initially VON1 is VO. Okay, so this is basically here subtraction will come. So this will VN2 is also VON. So Vin equals to 0. Initially Vin 0. Now how much V in we should apply so that current will stay fully. So here we have already find out. So this is V in equation. So new V in equals to for fully current steering from one device to another. So new value is VON1 dash, old value is VON2 dash, and VON2 is basically 0, and new VON1 is square root 2 of V on. Okay, so new V in is square root 2 V on actually. Okay, here VON and VON2 are equal because ID1 equals to ID2 and V in 0. So now we find out V in square root 2 V on. Okay, let's take example. So suppose now suppose we are having diff pair, and say here current is flowing is 2 milliampere, and here 1 milliampere, here 1 milliampere, and say this is VCM, this is VCM. Here V in input voltage V in 0. So if we write V in by 2 minus V in by 2, so here V in is 0, here V in is 0, and now we want some V in such that here current will, and here say suppose VON1 equals to VON2 equals to say V on equals to 200 millivolt. Now we want what is the value of V in, what is the value of V in VCM, V in by 2 VCM minus V in by 2, this is minus, such that this is 2 milliampere and this is 0 ampere, and here it is 2 milliampere. So for this V in we need to find out, so this V in is this, so this is square root 2, V on is here 200 millivolt we are assuming, so this will come 200 millivolt equals to 280 millivolt. Okay, we can understand this in this way. Say ID1, this is V on 1, this is ID2, this is V on 2. Initially V on 1, V on 2, 200 millivolt, ID1 1 milliampere, ID1, ID2 1 milliampere. Now in this case V in equals to 0. Now this goes to 0, so it means from this equation ID equals to beta VGS minus VT square, or this is V on, this current is 0 when V on is 0, so new V on 2 is 0. Now here this is 2 milliampere, so now new value of V on is square root 2 V on, or you can write it like a 280 millivolt. Okay, so how much delta change? So here delta V on change here is 200 to 280 means plus 80 millivolt, it will go up. Here how much delta V on will change? 200 to 2, so 0 minus 200 millivolt is minus 200 millivolt. So in this case new Vn is 280 millivolt. Okay, now here one point, important point we should note here is that for fully steering current one device to another device in diff pair, VON go up by smaller quantity and VO, this is one, VON 2 go down by larger quantity to make current equals to 0. Okay, to double the current. So it means quantity which is going positive side or increasing is less as compared to quantity which is going down. So this is a very important point to note down. Okay, now we are having another question. That question is how this tail node is going to behave. Vs is tail node, how it is going to impact by this change in Vin. So now initially here current is 1 milliampere which is changing to 2 milliampere. Here current is 1 milliampere and current changing to 0. So how this Vs will behave? It will go up or down. So it will go up or go down. So Vs will go up. Now question why? Let's understand this using example. Now say this is VCM and Vin is say go up. So Vin required is 280 millivolt. Okay, so Vin by 2 is equals to 140 millivolt. Now this is going up by 140 millivolt. This is going down by 140 millivolt. Now we need to find out how much Vs will go up. Okay, so how to find this? So now initial VON1 equals to 200 millivolt. Okay, new VON1 equals to 280 millivolt. So delta V on equals to 80 millivolt. Now this is VON, I will write it like this dash, this is new one minus VON1 old one, new one VGS dash minus VT minus VGS, this is 1, this is 1 minus VT. So this is new VGS, this is old VGS. So VT will cancel,